Hello, today in this video I'm going to go ahead and review graphing simple rational functions. You can go ahead and take down these examples on your notes from yesterday's notes. Remember that we are working with rational functions, and our first step in order to go ahead and to graph the rational functions is to identify our a, our h, and our k value. That should always be your first step in these problems. Here in this problem, my a value is a -3. My h value is a +1. Remember, I'm supposed to see a negative, a subtraction operation in the denominator, and my k value is a +2. So part A of this problem is they would like us to go ahead and find the equations of the vertical and horizontal asymptotes. So in this part, our vertical asymptote, remember, is x equals h. So my h value is 1, so therefore my vertical asymptote is x equals 1. My horizontal asymptote is y equals 2, and that's my k value. Y is always equal to k for your horizontal asymptote. That is y equals 2. Our second step in this problem is to go ahead and graph the function using a couple of testing points. So I want to plug in two values into my function d of x, and I'm going to pick my points very specifically. I want 1 point to the left of my vertical asymptote, and I'm going to go ahead and pick 0. So when I plug in 0, I get -3 over 0 minus 1 plus 2, giving me -3 over -1 plus 2. And this simplifies to 3 plus 2, which is 5. My other point I'm going to pick is 1 to the right of my vertical asymptote, which is 2, and that is d of 2. So plugging this in, I get -3 over 2, which I plugged in for x, minus 1 plus 2. This simplifies to -3 over 1 plus 2, which is -3 plus 2, giving me -1. So now that I've evaluated the function d of x at 0 and 2, I have 2 points, and these 2 points are 0, 5, and 2, -1. Okay, so what I'm going to do next is I'm going to go ahead and graph my rational functions. I'm going to plot my y-axis and my x-axis. Then I'm going to go ahead and plot my vertical asymptote, which is x equals 1. So there's my vertical asymptote. Remember to use dashed lines for your asymptotes. And now I'm going to plot my horizontal asymptote, y equals 2. Okay, so I have my asymptotes, and then I'm going to plot my 2 points that are going to be on my graph, 0, 5. So I go up 1, 2, 3, 4, and 5. Here's 1 point. And 2, -1. So I go to the right, 1, 2, and then down 1. So those are my 2 points. Remember, when you're graphing rational functions, from the left, coming from -infinity, my x values always approach my horizontal asymptote. So I'm going to come from there, and then I'm going to shoot up towards +infinity as I approach my vertical asymptote. And from my vertical asymptote, I'm going to go ahead and touch my point, and then as x goes to +infinity, I'm going to approach again my horizontal asymptote. Okay, so there is your rational function graphed. Part C, what they want you to do is they want you to identify the domain and the range of this rational function. So the domain of this rational function in interval notation is negative infinity to my vertical asymptote, which is located here at a positive 1. And I pick back up after my break at my asymptote, and I continue all the way to infinity. So there's my domain in interval notation. In inequality notation, it's just x is less than 1 or x is greater than 1, because x exists for all those values except for at 1, which if I plugged in 1 here for x, I would get 0 in the denominator, which gives me an undefined value. As far as my range, the range, well, that's just my y values. So I start from negative infinity and I go all the way up to my horizontal asymptote, which is located at 2. I take a break and I pick back up after 2, and I continue all the way to positive infinity. In inequality notation, this is y is less than 2 or y is greater than 2. Okay, and that is one example. Really quickly, I'm going to go ahead and do this next example. Here, my a value. In order to graph this, I need my a, h, and k. A is 2. H is a negative 3. Remember, we want to see subtraction in the denominator. And my k value tacked on at the end is a negative 1. So what does this mean for graphing? Well, this means my vertical asymptote is going to be located at negative 3. X is equal to negative 3. My horizontal asymptote is going to be my k value. That is y equals negative 1. And then I want to find 2 test points. One to the left of my x, my vertical asymptote, and one to the right of my vertical asymptote. So I'm going to go ahead and plug in negative 4, that's the value one to the left of my vertical asymptote, into my function r of x. And this gives me 2 over negative 4 plus 3. Take away 1. This simplifies to 2 divided by a negative 1, subtract 1, which is just negative 2, take away 1, giving me negative 3. So that means one of my points is negative 4, negative 3. Plugging in one value to the right of my vertical asymptote would be negative 2. So r of negative 2, I get 2 in my numerator. X plus 3 in my denominator is going to be negative 2 plus 3. Take away 1. This simplifies to 2 over a positive 1. Take away 1, giving me 2 minus 1, which is just 1. So therefore, my second point that I'm going to use would be negative 2, 1. Okay, I'm going to go ahead and now graph. I'm going to get to my x and y axis going here. So I'm going to plot y-axis, x-axis, and now I will do my horizontal asymptote. Y equals negative 1, that is down here. And my vertical asymptote, x equals negative 3, that's over here, 1, 2, 3. Okay, and I'm going to plot my 2 points, negative 4, negative 3, 1, 2, 3, 4, down 1, 2, 3. And negative 2, 1, so 1, 2, up 1. Okay, and I'm just going to sketch my graph. So coming from this direction, come down here, and from up here, I'm going to hit my point, and then go out towards my asymptote. I'm going to put arrows on this just to let you know that I'm going to infinity and beyond. And there is my simple rational function. Okay, I'm also going to go ahead and remember you have to include your domain and your range. So domain in interval notations, negative infinity to my vertical asymptote located at negative 3. Take a break. Negative 3, comma, all the way to infinity. In inequality notation, x is less than -3, or x is greater than -3. Range, those are my y values. The range, my function exists all the way from -infinity all the way to my horizontal asymptote located at -1, union -1 all the way to infinity and beyond. And then my inequality notation, y is less than -1, y is greater than -1, include my or. Okay, so those are a couple of examples on graphing simple rational functions using transformations.